We're given a fully discrete 10-year endowment insurance of $300,000 on age 50. The gross annual premium is $26,470. Initial non-commission expenses are $17,500. Commissions are 5% of all premiums. We can use the Standard Ultimate Life table. Interest rate is 5%. So L0 represents the loss at issue random variable. So we want to calculate the probability the loss is less than 0. So let's look at the formula first for the loss at issue. Is the present value of the future benefits plus present value of future expenses minus present value of future premium. So this kind of looks like the equivalence principle, but with the equivalence principle we're looking at the expected present value. And we set this equal to 0. Okay, so let's look at the future benefits. So this is a 10-year endowment insurance of $300,000. So the benefit is $300,000, and we don't know the time of death. So we're gonna discount it back k plus 1 years. Okay, now the future expenses. Well, the second bullet point says there's an initial non-commission expense of $17,500. So that's $17,500. We don't need to discount it because the expense is assumed to be the beginning of the year. And the third bullet point says the commissions are 5% of all premiums. So premium from the first bullet is $26,470. And this we represent with annuity due. And the last is the present value of future premium. Well, premium is $26,470, and then we have the annuity due. Okay. All right. So what I have underlined separates between the future benefits, future expenses, and future premium. So the next step is to do some algebra. So we're going to simplify this. So we're going to have 300,000 v to the k plus 1 plus 17,500, and here we have two annuity dues, so we can add those together. So we'll get negative 25,146.5 a double dot k plus 1. And see, so we're going to break up the annuity due. As 1 minus v to the k plus 1 over d. And then we can factor out the v to the k plus 1. So inside the parentheses would be 300,000 plus 25,146.5. And that's going to be over d, which d is I over 1 plus I. And I is just 0.05. Okay, so I'm skipping a couple steps here. V to the k plus 1, and then we're going to have the 17,500, and then minus 25,146.5 over d, where d again is this. So I'm just distributing out the 25,146.5. Okay, so the first one is here, and then the other one is over here. So again, we're going to simplify this, and we're going to get 828,076.5 v to the k plus 1 minus 510,000 576.5. And so this is the loss at issue. Okay, the next step, we want to calculate the probability that the loss is less than 0. So let's actually write it using a probability. So we want this whole loss less than 0. And for that, we're going to add the 510,000.5 to the right side and divide by 828,076.5. So at this step, V is 1 over 1 plus I, which is 1.05. And we can represent that as 1.05 to the negative 1 power. So V to the k plus 1 is just 1.05 raised to the negative k plus 1. And from there, we would take the log of both sides and simplify. So skipping a couple steps, we get that k is greater than 8.911. So this is a curtate. So k is a curtate life expectancy. We see here. So fully discrete. So this pays at the end of the year. And k is assumed to be an integer. So like if it was continuous, k could be basically a real number. But because this is an integer, it's the same thing as saying, okay, what's the probability that k is greater than or equal to 9? So from that, we were issued at age 50. So that's the same thing as someone age 50 surviving for 9 years. And one of the bullet points said we can use the standard ultimate life table for mortality. So that would just be L59 over L50. And L59 is 96,929.6. L50 is 98,576.4. And that simplifies to 0.983. And that's our final answer.